Today we're doing 10.7. This is a longer lesson, so I broke it up into 2 different days. So today we're doing part A. Part A is going to be over multiplying and dividing in scientific notation. So by the end of this lesson, you should know how to be able to do that pretty fluidly and come up with your own rules for multiplying and dividing in scientific notation. If you need to, pause at any time so you can catch up or try some problems. So let's start off with a review. I want you guys to pause the screen and try these 2 problems out. When you press play again, I'll have the answers on the screen. So for these 2 problems, you should have used the product rule because we have 2 bases and 2 exponents with multiplication in the middle. The product rule tells us that we're adding our exponents. So we have 5 to the 9th for A and 10 to the 15th for B. Now I have 2 problems that are going to be multiplying in scientific notation. So we're starting off with multiplication. The reason that I did that example for you is because we're going to be using the product rule in these problems. So the first thing that I'm going to do is I'm going to use the commutative property in order to change the order of this problem. I can use this because I can see that every single thing is being multiplied. So I'm going to group up by my like terms. So I see that those 2 are like terms, and I see that these 2 are like terms. And by like terms, I just mean that I'm grouping up by numbers with exponents and numbers without exponents. So we've got our 2 factors grouped up. I'm going to rewrite those real quick. So we've got 3 and then times 5. And I'm not getting rid of the multiplication between them. I'm just moving these numbers. And then we're going to group up our factors, or not our factors, our bases, our powers. So the first one is 10 to the negative 5th. And our second one is 10 to the negative 2nd. 10 to the negative 2nd. And now I'm going to be multiplying my factors and I'm going to be multiplying my powers. So when I multiply my factors, I have 3 times 5, which is going to give me 15. And then on the right side, I've got my 2 powers being multiplied. Again, I'm keeping my multiplication there. But we know from the product rule that all we're going to do is add those 2 exponents together. So we have our base is the same of 10, and then we're doing negative 5 plus negative 2, which is going to give us a negative 7. The last thing that we're going to do is we're going to check to see if this is written in scientific notation. Looking at my factor, I can tell that it is not currently written in scientific notation. I know that my factor has to be a number between 1 and 9, and it can also be 1. This is not, this is 15 currently. So I know the decimal place is right here. I'm going to be moving that decimal place over 1 time to get a factor of 1.5. Since I've changed my factor, I also have to change my exponent. Since my factor got 1 smaller, that means my exponent is going to get 1 bigger. So I'm going to add a 1 to it. Negative 7 plus 1 is going to give me a negative 6. Now this final answer has been written in scientific notation, so I know that it is done. I'm going to be solving this problem now. If you feel confident enough to look at what I have done and solve the second problem on your own, just pause and try it out and then check your answer at the end. If you don't feel confident, then just follow along with me. So again, the first thing that I'm going to do is I'm going to be grouping up my factors and I'm going to be grouping up my powers. So my two factors in this case are 7 and 3. So I'm going to write down 7 times 3. And my two powers are 10 to the second and 10 to the fifth. So I'm going to be grouping those up and writing them down. Now that I have those grouped up, I'm going to be multiplying my factors. 7 times 3 is going to give me a 21. And then I have to multiply my powers. So that's going to be 10, because we keep our base. I'm going to use the product rule to add those. 2 plus 5 gives me a 7. So currently we have 21 times 10 to the 7th power. I know that this isn't written in scientific notation because of my factor. And I know my decimal point's right there. So I know if I move this over one place value, that this number will be a factor written in scientific notation. Since this number got one smaller, that means this number is going to get one bigger. So we're going to add 1 to our 7. So we have 2.1 times 10 to the 8th power. And that's going to be our final answer because that is written in scientific notation. Now we have our McDonald's problem. So McDonald's has about 2.1 times 10 to the 5th managers, and each makes an average of $39,000 per year. The question is, how much money does McDonald's spend on managers each year? So I've bolded that important information for us. So we need this number here, and we need that number there, because it's going to be how much money does each manager make per year. So since I know that each manager is going to be earning that amount of money, I know that I'm going to be using multiplication. So I'm going to take those two numbers and I'm just going to multiply them. I know in order to multiply them, I'm going to have to do something to change it around a little bit, just so I can see and understand it better. So I'm going to take the second number here, and I'm going to convert it so it's in scientific notation. In order to get it from that to that, I moved the decimal over 4 places. Since it was getting smaller, that means that my exponent got bigger. Now I'm going to do what I did before, and I'm going to be grouping them up. So I'm going to group them up by factors and by my powers. Now I know that I can multiply my two factors, so I'm going to do that. And then I know that I'm going to be using the product rule over on the right side. When I do those two things, it can come together. So it equals 8.19 times 10 to the 9th power. Since that is written in scientific notation, I know that that's going to be my final answer. And if we wanted to answer the question, we know that they spend $8,190,000,000 per year on manager salaries. Let's move into some division. So here are two problems that you should know how to do. So pause the screen and try these two problems. So I know for these two problems, I'm going to be using that quotient rule. The quotient rule tells us when we have a base and an exponent divided by a base and an exponent, we're actually just subtracting those two exponents. So for the first one, part C, we have 5 to the 4th power, and for part D, we have 10 to the 5th power. Now let's try some division problems. This is basically the same thing that we did in multiplication. So for the first part, we've got to group them up. When we have two numbers written in scientific notation over top of each other like they are for this first problem, they actually kind of already are grouped up. So if we look at it as a numerator and denominator, I can see that this is going to be my factor and this is going to be my power here. So what I'm going to do first is I'm going to be solving 1.5 divided by 7.5, which when I put it in my calculator, I can easily find out that that is equal to 0.2. And then over on the other side, I have 10 to the negative third minus 2, because I'm going to be using that quotient rule. That's going to simplify. I'm going to keep change opposite, so I'm actually looking at the negative 3 plus negative 2, which is going to give me negative 5. So I know my factor right now. I'm going to change my color so it doesn't get super confusing. I know my factor right now is 0.2, and I know my power currently is 10 to the negative fifth. Now we're going to check to make sure that that number is written in scientific notation, and it currently isn't, which means we have to make this factor into a number that can be considered a factor in scientific notation. So since I moved that decimal place over 1 to the right, that got my number 1 bigger, which means that I need to get my exponent 1 smaller. So I'm going to subtract 1 from there. I'm going to use my keep change opposite method, which tells me that I can say negative 5, which is keep, change my subtraction to addition, and then do the opposite of that second number. So since it was a positive 1, it is now a negative 1. Negative 5 plus negative 1 gives me a negative 6. That number is written in scientific notation, so I know it's my final answer. Just like before, if you feel confident and you think you can do this second problem by yourself, then pause and just check your answer afterwards. If you're confused still, do the problem with me. So to start off, I can see that this first number is written in scientific notation, and the second number is just a number. It doesn't have that times 10 to the whatever power. But I know that I can multiply anything by 1. And I know that 10 to the 0th power is going to equal 1, because anything to the 0th power equals 1. So we can technically multiply that by 10 to the 0th power, which is going to allow us to group things up just like how we were before. So I told you before that it's a lot easier to group things up when they're written over top of each other. So what I'm going to do now is do that. So on the denominator, I'm going to be writing 4.6 times 10 to the 0th power. Now I've got my factor on the left and my powers on the right. In my calculator, I'm going to divide my two factors. So I've got 9.2 divided by 4.6, which equals 2. And then on my power side, I've got 10 to the 12th minus 0, using that quotient rule that we know. And I know that that's going to equal 10 to the 12th. Now I'm going to put those together. I know my factor is 2, and then I'm going to always multiply it by 10, and this time it's to the 12th power. That number is written in scientific notation, so there's nothing more that we need to do. We have another word problem. So this time each year, the United States spends 7.7 times 10 to the 11th power of dollars on students in public education. There's approximately 77 million students in the public school system. how much money does the United States spend per student? So since I see that word per written there, I know that this is going to be a division problem. So what I'm going to be doing is I'm going to be writing these two numbers next to each other with division in the middle. So dollars per student, which is why my dollars number went first and my student number went second. I can't really look at this as is, just like that McDonald's problem. I'm going to convert this into a number that's written in scientific notation. And so that's what I did on the denominator. So I also grouped that up so it's over top of each other. I can see that my factor is 7.7 and I moved that decimal over 7 times to get 10 to the 7. Now, just like before, I'm dividing out my factor, which is going to give me a 1. And then I can see that I'm going to be using the quotient rule. So I'm going to be subtracting those two numbers in my exponent. So my factor is 1 times 10 to the negative 4th. Since that number is written in scientific notation, I know that I'm done. To actually answer that question of how much money does the United States spend per student, it's going to be $1,000 or $10,000 per student, because we're moving that decimal again over 4 times. So we're right here currently. We're going to move it over 1, 2, 3, 4 times. So I'm going to add those zeros in, and that's going to be $10,000. Now I want you to try these two problems by yourself. One of these problems is division, one of them is multiplication. So make sure that you're doing the correct operation. Pause your screen now and I will give you your answers when you're ready. And here are your two answers written in scientific notation. So for the first one, you should have gotten 2.9 times 10 to the negative 3rd. For the second one, your answer was not written in scientific notation, so you had to convert it to be in scientific notation. So it's going to be 1.5 times 10 to the 0th power. Now I want you to pause this video and describe the process of multiplying and dividing numbers in scientific notation using 3 easy steps. So if you need to, look back at what we did before, and I want you guys to come up with 3 steps on how to solve a multiplying or dividing problem that's going to be in scientific notation. These are the rules that I came up with. So you're going to group like terms. So by like terms, remember that I'm talking about grouping your factors and grouping your powers together. And then you're going to be multiplying or dividing those factors or powers. And then at the very end, you're going to check to make sure that it's in scientific notation. If not, put it in scientific notation. Your homework tonight is going to be IXL. So you've got 2 different IXLs. So since I'm assigning 2 different ones, I'm going to just have you get up to 50% on them. So your first one is G4, and your second one is G8, and or G5, and those are both 8th grade standards. If you've got any questions, send me an email.